Which type of catalyst is ethanol or ethyl alcohol in the following reaction? So this CHCl3 is called as chloroform. Everybody might have heard about it. So there are other names of chloroform also. We can even call it as methyl trichloride or trichloromethane. So I'll write that. See, for me, it's never about like you get the question and you just jump to the answer. So I try to give you added information wherever I can. So methyl trichloride also you can call it, or trichloromethane. So it is reacting with oxygen. So it's a combustion happening in the presence of this ethanol. That's a formula of ethanol, C2H5OH, and it is giving us phosgene. This is a gas. It's a very toxic gas. So phosgene, or we even call it as carbonyl chloride, along with HCl. So now, this is very much experimental question, like because until unless we don't know the background information of this question, we can't answer it. Now we know that chloroform is, you can say, we should not. We should not actually inhale it. So it's again toxic, and its combustion is happening, and it's giving us another toxic gas, COCl2 and HCl. So obviously, what we can do with this reaction? Do you think that this reaction for this ethanol is going to act as a positive catalyst? Whether this reaction is very much, you can say, slow? No, it's a very fast reaction. These are gases involved over here. So it's a fast reaction. So in this case, we will try to slow down this, you can say, highly exothermic reaction. It's a highly exothermic reaction. A lot of heat energy is also released. So we have to slow down. So for slowing down, which kind of catalyst we can actually put? We can add a negative catalyst. So C2H5OH is going to be acting as a negative catalyst, which is going to decrease the rate of reaction. It's not going to increase. We don't want increase in this reaction. But yes, a little experimental data, we can say, related to the lab. If we don't have information, the background information about this, then we can't predict the answer in this. So we need to have the background information. Positive catalyst, so this is the answer, but we can actually explore the other options, what these are. So we have positive catalyst, which increases the rate of reaction towards the forward side, towards the product side. So negative catalyst, it's going to decrease the rate of reaction towards the, you can say, the reactant side. So we have to slow down. Then we have biocatalysts. These are nothing but enzymes. Enzymes are nothing but biocatalyst. Definitely, it's not acting as a biocatalyst over here. Autocatalysts are slightly different. These are actually reactants in the chemical reaction. They are a participant in the chemical reaction, but they're also catalyzing the chemical reaction. We can discuss that in the future classes somewhere else. But yes, autocatalyst, auto in chemistry means self. So these catalysts are nothing but, you can say, chemical reactants in the chemical reactions, and they catalyze the reaction, so they are doing the dual job. They are also participating in the chemical reaction, which is very contradictory to the catalyst definition, but they are self catalyzing. So they are acting as a catalyst in the reaction also. So chemical reactants in the chemical reactions.